Hey Shubham, good afternoon. How are you, buddy? Am I audible, right? Yeah.
Hi guys, let me know. Am I audible, right, for everyone? Hi hi Shraddha, hi Shubham, hi Zede. Am I audible? Let me know in a chat box, guys. We'll start our session within 2 minutes. Okay. Just I want to check once whether it is a live or not. Do text me in a chat box. Am I audible, right? Yes, it is clearly audible to everyone. Chat, okay, it's done. Guys, let me know, is my audible? Am I audible to everyone? My screen is visible to everyone, right? Please text me in a chat box once. Or else confirm me through this poll. Actually, I launched one poll here. Okay, do participate in this poll. I will get to know that am I audible to everyone? Yes, that's great. That's great, buddy. Okay, good. Yes, thank you. Thank you for your response, guys. Hi, hello, everyone. Once again, this is Sham. I'm working as a physics faculty in JNV Haveri at Avanti Fellows. And today I'm going to explain few topics which is related to the heat and thermodynamics. Guys, already we started this chapter 2 days back itself. Meanwhile, I think Friday itself we started. Okay, two concepts which are already completed. And today onwards, we are going to take two more concepts here. We are going to discuss today the topics which are like bimetallic strips and specific heat capacity and numericals. Okay, these are all the things which I'm going to discuss today class. And meanwhile, along with this one, actually last class we are not at talk about the coefficient of the areal expansion of materials and as well as the volume expansion. Okay, we'll talk that one also. Hey, hi, may I know your name? There is no name. That's why. Cool. Yes, we'll start our session, right? This is the right time. I hope everybody came. Yes, before starting that, we'll take a quick recall what we discussed in our previous class. Actually, in our previous class, we talked about the different scales of temperatures. Correct now? Here only, especially we are talking about the four scales: Celsius scale, Kelvin scale, Fahrenheit scale, and as well as the Raman scale. Celsius scale, based on the scales are measured based on the ice point and as well as the boiling point of water. Right? ये दोनों को ऊपर डिसाइड करता है. क्लियर है ना? सेल्सियस में 0 डिग्री सेल्सियस था, 100 डिग्री सेल्सियस इज द बॉइलिंग पॉइंट ऑफ वाटर. केल्विन में भी सेम, केल्विन में भी 273 आइस पॉइंट, बॉइलिंग पॉइंट था 373. In Fahrenheit scale, 32 degrees Celsius is the ice point, and as well as the boiling point of water will be 212 degrees Celsius. And in Raman scale, ice point था 0 degrees Celsius, boiling point था 80 degrees Celsius. Right? And moreover, to convert from one scale to another scale, we derived one formula. Right? We derived one formula. For example, I want to convert the Celsius scale to Fahrenheit scale. Means I need to write like this: Fahrenheit scale minus ice point of water divided by boiling point of water in that Fahrenheit scale minus ice point of water is equal to a constant value. That's why we need to convert which quantity, that quantity we need to write here again. Degree Celsius minus ice point divided by boiling point minus ice point. Right? By using this formula, we can convert the any scale, Raman, Fahrenheit, Kelvin to Celsius or Celsius to another one. Okay, na? Right? And later on, we talk about the thermal expansion. Right? Thermal expansion, actually, I given an introduction in 1D thermal expansion, 2-dimensional, and as well as the 3-dimensional expansion. 1-dimensional expansion is basically like linear expansion. Okay, lengthwise expand hota hai. Area also expands, a volume also expands in linear only, but the quantity of expansion of area and as well as the volume is very negligible. That's why here only significant value is length. कौन सा है इधर? Length is the significant value. That's why we call this one as an thermal expansion and linear one. I given a few good examples also, daily life examples. And coming to the thermal expansion in 2D, that is a areal expansion. Either length and as well as the breadth. दोनों क्या होता है? Increase होता है. Right? We call that one as an areal expansion. And coming to the third one था cubical expansion. Means 3-dimensional expansion होता है. Clear है ना? These are the topics we covered. And linear expansion में कुछ चीजें बस बोल दिए थे मैंने आपको. क्या है? This is the initial length of the rod. If I give some amount of heat to this rod, ये heat देने की वजह से क्या होता है? ये rod में delta L length change होता है. Correct ना? This change in length is due to the given amount of heater. And then temperature difference होता है. Correct ना? And also I told that each and every material has their expansion different. Means मान लो copper है इधर, first copper 1 meter का copper wire था. If I give the heat to the copper, means in 1 meter it will be expand only 1.7 into 10 to the power of 5 meter, 10 to the power of minus 5 meter only. If you're going to give the same amount of heat what you provided for the copper, same amount of heat if you're going to provide for the steel for the same length, okay, where increase in temperature only 1 degree Celsius, in that temperature it will be expands only 1.2 into 10 to the power of minus 5 meter. Means each and every material expansion property is changing. Correct now? That property we find out, right, for the linear expansion here. How we find out it? Actually, delta L is the change in length, or DL also change in length, koi problem nahi. DL is proportional to change in temperature of that material we took, and then DL is proportional to original length also. And by using these two equation, we write like this: DL is actually proportional to length and as well as also temperature. Here proportionality constant hai. Actually delta L, change in length, not exactly equal to these two quantities which are right side, right? Actually we need to replace this one by a constant quantity. We call this constant quantity as an alpha. Okay, alpha we called, it's an linear expansion coefficient constant quantity. Simply we can say coefficient of linear expansion. This is what alpha, right? This alpha you need to find out, means take L into delta T to right hand side. Then value of alpha will become most to be change in length by original length into change in temperature. This is called coefficient of linear expansion. Guys, this value is changing for every material. It is not same for all the material, right? Understood, right? And इसका SI unit भी निकाल दिया थे हम. कैसे? Change in length means length ही है. Length के लिए SI unit क्या होता है? मीटर. Divided by इधर एक length है. Length का SI unit मीटर. And delta T means change in temperature. Correct ना? Temperature के लिए SI unit क्या होता है? Degree centigrade obviously, or else you may use the Kelvin also. Okay, इधर length and length cancel हो गया. Remaining thing will be in denominator, it is degree Celsius. If it is comes to numerator, power minus 1 होता है. Means per degree centigrade is the SI unit for coefficient of expansion, linear expansion. This is all about the points which we discussed in the previous class. Guys, let me know, is there any doubt? Is there any doubt? Do participate in the chat box. Okay. 3:31 more PM. Ashwini, Kedar, Sakshi, Shubham, Shraddha, Swapnil. Hope it is clear, right? The concepts which we are talking up to last class. Try to put a message in a chat box, yaar. Whether are you searching the chat box or not? Signal chat box elide anta. Okay, cool. Okay, we'll start today. Aerial expansion. Thank God. Yes. More Prasad. Thank you. Yes, guys. Finally, I got a response. I'm happy. Okay, we'll move on further. It's the second thing is that superficial expansion. We can say this one as an aerial expansion. What kind of expansion this one, guys? Aerial expansion. Likh do idhar. Aerial. Okay, area expand होता है. मान लो इनिशियल टाइम में इसका लेंथ था ए ऑब्जेक्ट का L, ब्रेड्थ था, this is also B. We can say this one as an L itself. कोई प्रॉब्लम नहीं, कोई प्रॉब्लम तो नहीं है. Okay, and then after supplying amount of heat को actually we are representing with the letter Q. Thermodynamics में heat को Q letter से represent करते हैं. After giving some amount of heat Q, this same material expands like this along length and as well as breadth. दोनों change होता है. Along the length, if I want to write this length, means I will write this one as an L plus DL, small change in length. पहला L था, उसके साथ DL length change हो गया. In bottom में here also breadth था before giving the heat B. After giving the heat, here also it will change us to dB. Here both are length only, right? Now here expansion coefficient or else how the material will be dependent based on this change in length, we need to find out. क्लियर है ना? नाउ गाइस देखो टोटल एरिया कितना चेंज हो गया उसको देखना पड़ता है हमको. कैसे देखना पड़ता है? देखो इधर dv, सॉरी पहला लेंथ एरिया था, सॉरी बार्डन फॉर जस्ट अ मिनट बर्डन हो गया इधर. इसका प्रीवियस एरिया विल बी ये. नाउ इसका एरिया विल बिकम ये प्लस dv. करेक्ट ना? एरिया पहला था कितना है था ना एरिया, उसके साथ साथ dl इंटू db मल्टीप्लाई होता है ना, इसलिए dv. अरे यार देखो इधर ये एरिया का फार्मूला क्या होता है? लेंथ इंटू ब्रेड्थ ना. दिस इज द इनिशियल वन. ये क्या है? इनिशियल. ओके, आफ्टर गिविंग हीट देने के बाद में एरिया क्या हो गया? विल राइट जनरली ये प्लस dA, सॉरी dv नॉट dA, ये प्लस dA. इधर देखो लेंथ मींस क्या हो गया? लेंथ में L प्लस DL हो गया ना लेंथ. ओके, इनटू B ब्रेड्थ में क्या होता है? अगेन B प्लस DB. दोनों लेंथ ही है, मल्टीप्लाई करो आपको इधर L स्क्वायर मिलता है, L इंटू B. ओके, L स्क्वायर प्लस DL इंटू DB. इधर एक्चुअली पूरा मल्टीप्लाई करना है. एक बार आपको क्या मिलता है? DL इंटू DB मिलता है. DL means it is very small value. DB also very small value. If you're going to multiply DL into DB means it will give much smaller value than DL and DB. That's why we are going to neglect these terms. Okay, then here we will get DL square only you will write. कोई problem नहीं. Then we will write this one as an L square. It is nothing but area plus DL square. We can write this one as A square plus DA square. Okay. DA, ये स्क्वायर नहीं, L स्क्वायर मीन्स एरिया ओनली. सॉरी क्या हो गया मुझे आज? कुछ हो रहा है. हे पैसा नहीं. ओके, L स्क्वायर मीन्स हियर एरिया, हियर DL स्क्वायर मीन्स इट्स अ चेंज इन एरिया, स्मॉल वन. ओके, राइट? नाउ वी नीड टू एक्चुअली फाइंड आउट, we need to find out the coefficient of expansion of area 1. okay, areal coefficient we need to find out. Here change in area है ना, actually देखो इधर change in area is actually proportional to same what we discussed in our length. No, here also we'll write the same thing. First one, change in temperature, nothing but dt, right? And again this change in length nahi, area. okay, change in area again it is proportional to initial area. ये दोनों को ऊपर डिपेंड होता है. I will call this equation number 1, I will call this equation number 2. clear है ना guys? Meanwhile if you are getting any doubt means please drop your doubt in a chat box. okay, ये दोनों सेम ही चीज है. That's why I'm going to combine these two equation. Hence it will become dA is proportional to A into dt. clear? Actually dA, what is the change in area is not exactly equal to area into change in temperature. It is actually proportional. That's why we need to replace this proportional quantity and we need to introduce one equal. correct now? That's why we need to introduce here one constant quantity. The constant quantity which I'm going to introduce here, I will call this one as an beta, right? Beta into A dt, right guys? This is what actually change in area. clear now? And then here beta hai na, this beta we are going to call this one as an coefficient of areal expansion. Coefficient of areal expansion we will call. cool. And then if you want to find out the value of beta, then क्या करना है इधर? देखो ये दोनों टर्म को लेफ्ट हैंड की तरफ लेके आना. then it will become dA divided by A dt is equal to beta आता है. देखो, right? This is the expression for coefficient of areal expansion. I hope you guys understood, right? Let me know in a chat box once. Guys, let me know. Coefficient of expansion is clear, right? Yes, Shubham, thank you. And I want to know one more point here. May I know what is the SI unit for this one? SI unit क्या होता है इसको? SI unit. Who will give the first answer? I'm waiting for your answer now. What is the SI unit for this one? Actually, coefficient of aerial expansion. Actually, this is a coefficient, constant quantity. Is it constant quantity? Only for a material. Okay. Now I want to know what is the SI unit for this one. Beta के लिए SI unit क्या है? उधर अल्फा के लिए SI unit आ गया था पर डिग्री सेंटीग्रेड और सेंटीग्रेड इनवर्स. इधर क्या आता है? देखो इक्वेशन में क्या है? यस यस सेम dA अपॉन A इंटू dt है. करेक्ट ना? Right? SI unit, when you are writing SI unit, we need to write this one in a simple form. dA means it is nothing but area. Area के लिए SI unit क्या होता है? मीटर स्क्वायर divided by area है. This is also meter square. Denominator टेम्परेचर के लिए SI unit क्या होता है? डिग्री सेल्सियस और केल्विन you write. Okay, डिग्री सेल्सियस if you write means ये मीटर स्क्वायर get cancel. डिग्री सेल्सियस इधर प्लस है पावर. If it is comes to numerator, इसका पावर क्या होता है? -1. Hence degree Celsius inverse is a SI unit for a beta. Clear? Hope it is clear. इधर also beta के लिए also ये SI unit होता है inverse of degree centigrade. Clear है ना? I'm asking everyone. Hi Bhavna, Ashwini, Kedar, Prasad. Yes. Shraddha. Hi Rituja. Yes, right guys. Right. Okay, good. Hope you all understood this one. Coming to the next point. Next point क्या है? Volume coefficient of expansion. Similar, same तरीका है. कोई change नहीं है. इधर also same thing. I'm trying to explain little faster way. Length ये है. This is breadth. Actually, वही भी length होता है. And then this is also one. Okay, मान लो ये height है. This is breadth. Okay, we can write this one length into breadth into height. We can also write this one as an length into length into length only. कोई problem नहीं. After giving some amount of heat, Q amount of heat, the volume lengthwise also means देखो इधर ये length भी increase होता है, ये length भी increase होता है, ये length भी increase होता है. Means 3-dimensional expansion will be takes place here. कितना? 3-dimensional expansion will be takes place. When 3-dimensional expansion will be takes place, we call this one as an volume expansion. We call this one as an volume expansion. That's why initial volume था V. इधर volume क्या रखना है हमको इधर? V plus dV. This is what the change in volume. Clear? Now we need to know what is the parameters which is depending upon this change in volume. Again, change in volume is directly proportional to the initial volume. I'm going to call this equation number 1. Second equation है this change in volume actually again proportional to the change in temperature. Before giving this amount of heat, the volume is having some certain temperature. We can call this one as an T1. After giving the heat, the temperature will be changes to T2. Means change in temperature also proportional to the value. Okay, that's why I will call this equation number 2. ये दोनों मिला के what I will write here देखो again dV is proportional to V dt. Sorry, dt लिख दो इसको. Guys, I want to know one more point. I will say end of this equation. Okay, very curious equation. Okay, and again to change this proportionality constant, I will bring one constant value here. देखो dV is equal to, I will call this one as an gamma. एक क्या है? Gamma. Gamma is the कोएफिशिएंट ऑफ एक्सपेंशन ऑफ वॉल्यूम, वॉल्यूम कोएफिशिएंट का एक्सपेंशन होता है गामा, राइट, इनटू v इधर से है एंड एज वेल एज चेंज इन टेम्परेचर dt. ओके, दिस इज द चेंज इन वॉल्यूम इक्वेशन हो गया. इफ यू वांट टू फाइंड आउट, लिख दो इधर, गामा वी कॉल्ड कोएफिशिएंट एक्सपेंशन ऑफ वॉल्यूम, वॉल्यूम का कोएफिशिएंट ऑफ एक्सपेंशन होता है. And the gamma value, देखो gamma value you want means take these two terms to left hand side, then it will become dv divided by v dt. We got final answer again in a same pattern, correct now? And again if you are going to write the SI unit for this one, SI unit क्या होता है, देखो ऊपर वॉल्यूम है, वॉल्यूम के लिए SI unit क्या होता है, मीटर क्यूब होता है, divided by denominator में also volume cube is there, volume is there, meter cube, and change in temperature will be degree centigrade. Here these two will be get cancelled, hence SI unit will becomes out to be again degree centigrade inverse, or else you may write this one as an Kelvin inverse also, कोई problem नहीं, दोनों correct answers है. Yes, yes Swapnil, right bro, right dude. Okay bro, actually for everyone I have one small question to all, as possible as quickly try to drop your answer. What is the difference between delta and d, means delta x dx, ये दोनों को बीच में रिलेशन क्या है, और what is the difference between these two? I will write once again. क्या है ना, मेरा क्वेश्चन ये है डेल्टा x एंड dx का बीच में डिफरेंस क्या है. मैथ्स में आता है ना, बोलो व्हाट इज द डिफरेंस बिटवीन डेल्टा x एंड dx? Guys, untick yourself. Those who are given a response, no. Prasad. What is the difference between these two things? Delta x stands for, guys, actually you know the value is 2.51 minus 2.50 है. ओके, ये दोनों का बीच में डिफरेंस कितना है, इसको हम बोलते हैं डेल्टा एक्स, स्मॉल चेंज इन वैल्यूज. dx कब यूज करते हैं ना हम, मान लो द वैल्यू विल बी लाइक दिस 5.00021 और डिफरेंस बिटवीन 5 दिस टू वैल्यूज 0.00011. हियर क्या है, देखो जीरोस बहुत ज्यादा है, राइट, हियर द जीरोस विल बी वेरी लार्ज, दिस काइंड ऑफ वैल्यूज व्हिच इज रिप्रेजेंटेड बाय dx. Okay, small value change in represents by small delta x. Clear है ना, delta x means small number of values. ये dx है ना, सिंपल से बोलता हूं मैंने, डालो 0.000000. आप कब तक जिंदा रहते हैं ना, अब तक जीरोस डालो zeros. When you are going, put 1 that time. Okay, this much of small quantity which is represented by dx. Clear? Hope it is clear, right? The session will be based on you people only. Okay. How fastly you will give the reply, that much fastly the concept will be going, means forward चलता रहता है. Yes, good, thank you, good. शुभम कहाँ गया भाई? हाँ, okay. Okay, now the relation between alpha, beta and, okay, here printing mistake हो गया, इधर जोड़ दो gamma. ये तीनों dx is differentiation. Yes, right. Differentiation is nothing but, guys, actually small values को find out करना है हमको. Okay, differentiation form, कोई problem नहीं. अच्छा, okay, that's good. Okay, linear expansion में we are using the coefficient alpha. in aerial expansion, superficial expansion, we are taking beta, and in volume expansion, we will take gamma as an coefficient of expansion, constant quantities. What will be the relation between these three quantities? We need to find out. First, we will take about the we'll find out the relation between alpha and as well as beta. ये दोनों का बीच में क्या relation है? Okay, basically we know guys, dv change in volume का आंसर आ गया था हमको बीटा a dt आ गया था, करेक्ट ना? I will call this equation number 1. किसके लिए? इसके लिए, करेक्ट है ना? Now देखो इधर, actually we know that v is equal to l square, means sorry a is equal to l square. area को we can write length into breadth, that is a l square. If I do partial differentiation दोनों साइड में, क्या कर रहा हूं मैंने? पार्शियल डिफरेंशिएशन कर रहा हूं मैंने. Okay, what will become here? area will come dA is equal to, इसको डिफरेंशिएशन करने में क्या होता है? 2l into dl होता है. This is called the partial differentiation. Okay. Yes, Prasad. Yeah. Is any question? Okay. Cool. We got one equation for dA. क्या है? dA is equal to 2l into dl. Right here, what I write? dv not dA. This one, first equation. Clear है ना? Now I will put this equation number 2 in this equation number 1. Equation number 1 में क्या कर रहा हूँ? Put कर रहा हूँ मैंने. Equation क्या आता है? देखो, dA means here लिख दिया है 2l into dl is equal to beta into area, means it is nothing but l square ना. I will put here l square. देखो, actually this is a question which is asked in NEET. NEET question है. What is the relation between alpha, beta, gamma? I'm explaining that one only. Please be conscious here. Okay, and then dt. Clear है ना? And also we know that guys, dl, here dl के equation क्या आ गया था? dl will be equal to l alpha dt आ गया था. I will substitute here the dl value. Then 2l into l means again this value. Substitute here l into alpha dt is equal to beta l square dt. इधर dt से dt मर गया, गायब. इधर l into l means l square, this is l square, गायब. रिमेनिंग थिंग क्या है? देखो एक बार गाइस, इधर 2 बचा हुआ है and then alpha बचा हुआ है, इधर beta, means beta value will be equal to 2 times the alpha. क्या आ रहा है? beta value is equal to 2 times the alpha आ रहा है. Means aerial expansion में alpha will be expand only one dimension, but in beta क्या होता है? 2 dimensional में expansion होता है ना. That's why it is equal to 2 times the beta. Clear, right? Let me know. Prasad, I didn't get your question. Actually, sir, आपका अपना नाम बता दो ना. Actually, my name is Sham. My name is Sham. Before, at the time you are not there, I think. Okay, कोई problem नहीं. Is it understood for everyone, right? Beta का value क्या होता है? Beta का value होता है 2 times the alpha. Is it clear for everyone? Let me know. अरे मेरे प्यारे बच्चों, बोल दो. Beta का value क्या होता है? 2 alpha. Is it understood, right? Yes, good. How many of you are from Karnataka here? कर्नाटका से कौन कौन आया इधर? No one is there, right? Okay, कोई problem नहीं. And one thing is over. Now we'll discuss about the second one. क्या है second one? Actually alpha को we need to relate with the volume. Volume वाला. Volume में कौन था इधर? Gamma. Gamma and alpha का बीच में relation क्या है? डिस्कस करना वाले हैं हम. गामा वॉल्यूम के लिए इक्वेशन आ गया था हमको, dv is equal to v gamma dt, right है ना? And then we know that it is nothing but l cube. Again do partial differentiation here. We will get dv is equal to 3l square into dl, 3l square into dl. Correct now? Now substitute this value in this equation. Substitute karo left hand side ko. After substitution, you will get 3L square dl is equal to V gamma dt. V gamma dt. But guys, इधर dl है ना, dl के लिए हमको एक इक्वेशन बता है, क्या है वो? dl is equal to L alpha dt. It's a linear expansion वाला. Substitute करो इधर. Again 3L square dl का प्लेस में L into alpha dt is equal to right hand side में इधर V है. V is nothing but volume. Volume को we can write as an L cube. इधर already I took no. That's why L cube gamma dt. इधर L cube, L square into L cube दोनों cancel हो गया. And then dt cancel हो गया. Then gamma value will becomes out to be 3 times the alpha. 3 times the alpha. Hope it is clear for everyone, right? Hope it is clear. Gamma के साथ alpha कैसे relate हो गया? 3 times the alpha means length, breadth, width तीनों भी expand हो रहा है. Clear है ना? And we can relate this one in a single format also. कैसे? Alpha value is equal to, okay, alpha is to beta is to gamma. If I'm going to write like this, okay, beta is equal to 2 times the alpha, and then gamma is equal to 3 times the alpha. Correct now? We can write this one in the ratios. In the ratio, alpha is to 2 alpha is to 3 alpha. Correct है ना? देखो एक बार. And if you're getting any doubt means drop your doubt in a chat box. This is a neat question. This is neat question. Hope it is clear, right, for everyone? Yes, Prasad, good. अरे यार, इतना members है. At least you have to respond, no? Swapnil, Sanket, Sakshi, Rutuja. I got the response from Prasad. Good, bro. Okay, we'll move to the next point. Next point है bimetallic strip. Guys, this is also one of the important topic as per the JEE syllabus. Okay, a bimetallic strip क्या होता है? First, I will tell you the application. क्या है bimetallic strip? When you are doing ironing your shirt or your clothes, okay, your iron box after 2 to 3 minutes heated, okay, it will be automatically switch off होता है, right? How it will be work? Actually, it is basically working on the principle of bimetallic strip. What is this bimetallic strip? Means 2 metals होता है. I will call this one as an A. This is B. ये दोनों मेटल को क्या करता है ना, बहुत स्ट्रॉन्ग फोर्स से इसको रिवेट करता है. बहुत स्ट्रॉन्ग फोर्स से रिवेट करता है एक के ऊपर एक. Okay, you can't able to open these 2 strips by your applying force directly. Okay, इधर क्या है? If I am going to give some amount of heat to this bimetallic strip, it will be bent. क्या होता है? Bent होता है. Bend. कैसे bend होता है? That is what we want to know. How it will be bent. इधर 2 मटेरियल ले लिया मैंने, A and B. मान लो मैं बोलता हूं ये है कॉपर, ये है स्टील है. Guys, I want to know for which metal out of copper and as well as the steel, which one having high bending strength, or else we can say high expansion, linear expansion किसको ज्यादा है? Alpha value is more for which of these 2 materials? Let me know. Alpha value means मान लो I give amount of heat to this material. which one will be increase their length more compared to these two, copper or steel? Yes, good good. कॉपर का एक्सपेंशन बोल दिया था मैंने उस दिन 1.72 into 10 to the power of -5 per degree centigrade, है ना? एंड देन स्टील का कितना था 1.2 into 10 to the power of -5. इधर स्टील कम लेंथ एक्सपैंड होता है, कॉपर एक्सपैंड्स मोर. गुड, राइट? मान लो आप ये दोनों का इनिशियल लेंथ था L, दोनों का इनिशियल लेंथ क्या था? L था. दिस इज कॉपर एंड दिस इज steel. Now copper will extends more than the steel, means copper का actually लेंथ ज्यादा होता है. इसे देखो क्या होता है, एक्चुअली बेंड होता है. कैसे? ऐसे. this will become copper and this one will become steel. now ऐसे बेंड हो जाता है. राइट? आर यू गेटिंग माय पॉइंट? व्हाट आई एम सेइंग, एक्चुअली बेंड हो जाता है. कैसे कैसे कैसे? वेट करो, देखो. मान लो दिस इज द, आई होप इट इज विजिबल राइट फॉर एवरीवन. जस्ट अ मिनट, आई विल ओपन माय कैमरा. yes, मान लो this is the bimetallic strip. From this point I will give the heat, from this point I will supply the heat. मान लो lower bottom है ना, this is actually made up of steel. this ऊपर वाला है ना, it is actually made up of copper. okay, if you give the heat anywhere, either you give from here or give from here, okay, copper will absorb the heat very fastly and it start to expand. एक्सपेंड होता है, बट एक्सपेंड होता है मींस ये बीच में होता है ना स्टील, वो भी एक्सपेंड होता है, बट द एक्सपेंडर विल बी नॉट कम आउट हियर. इंस्टेड ऑफ दे विल बी बेंड लाइक दिस, they will bend like this because they are riveted very strongly. With a strong force they are riveted. It's the same process, it will be worked in a iron box. कैसे होता है? एक्चुअली ये connecting wire है. मान लो initially when you are switching on it, no, that time when you switch it on, these two will be in contact like this. Metal and wire will be contact. At the time the bottom of the iron box will be heat. In the same way, after current passing, Joule heating effect pada hai na aap, current will be passing through this bimetallic strip. After heating certain temperature of this bimetallic strip, ये क्या होता है? ऐसे bend हो जाता है. When it will be bent, okay, the connection between these two will be disconnected. When these two will be get disconnected, at the time circuit will be breakdown. Guys, observe when you are ironing the clothes, after few seconds, a few seconds means 2 to 3 minutes after, okay, you will get a sound tuck. After then connection will be lost. After cools down this one, again it will be like this hota na, again it will comes to the normal state and it will touches the wire and again circuit will be again reconnected. okay, it is actually basically working on the principle of bimetallic strip. Hope it is understood to everyone, right? हो गया ना? अरे यार बोल दो ना. okay, now copper है ना, this copper I will take this one as an increasing length L2. I don't know how much amount of length it is increased. and steel का I will write L1. दोनों को लेंथ इंक्रीज होता है आफ्टर गिविंग सम सर्टेन अमाउंट ऑफ हीट देने के बाद में. इधर क्वेश्चन आता है गाइस, इट इज लुकिंग लाइक अ आर्क, लाइक ना, दिस इज लुकिंग लाइक आर्क, राइट? दे आर आस्किंग द क्वेश्चन लाइक दैट, व्हाट इज द रेडियस ऑफ दिस आर्क? क्या पूछते हैं आपसे? रेडियस ऑफ द आर्क बोल दो, पूछता है ऐसे. रेडियस को पता करना है आपको. क्या पता करना है? रेडियस. ठीक है ना? and you are getting any doubt means please drop your doubt in a chat box guys. okay, no need to hesitate. and then radius calculate करने के लिए it is actually semi arc of a circle. now what I will do, I will extend this length up to this point. ऐसे इसको भी मैंने ऐसे extend करता हूँ, करेक्ट ना? ये दोनों को बीच में क्या हो गया? थोड़ा सा एंगल क्रिएट हो गया. We can call this one as an theta. Theta is an angle which is created between these two arcs. Clear है ना? And from this point to O, okay, I will call this point as an A to O, the distance is there, no, we call this one as an radius. And the remaining distance here, we can call this one as an D. It is a thickness of the bimetallic strip. Thickness very small होता है, very small. Clear? Up to this point is understood to everyone, right? If you are not understanding means, please let me know in a chat box. Okay. And coming to the point, देखो इधर, guys. Actually, change in length होता है ना? Change in length, how we will write? dl is equal to L alpha dt. L alpha dt ना? This is a general formula. कौन सा formula है? General formula. इधर change in length. Yes. Thank you, Sakshi. Thank you for giving a response. Okay. Here length L2 is there, no? This is the change in length for copper. किसके लिए है? Copper के लिए है. Copper के लिए I will write the change in length here. L2 will be equal to initial length क्या था? L ही था. Write down here L alpha dt, temperature change. Clear? I will call this equation number 1. Next, change in length L1 है. This is for steel. Steel का भी length change होता है ना? I will write this one as an L1 is equal to initial length था L, उसका भी here ही itself. दोनों same length था. Alpha is the coefficient of expansion of the steel here. This is steel. I will call, okay, simply I will mention different things here. क्योंकि alpha value also changes here. I will call this one as an alpha 1. I will call this one as an alpha 2. Right? Here bending हो गया ना? Alpha 1 is greater than alpha 2. Means copper का expansion coefficient ज़्यादा है comparatively steel वाला. That's why copper expands more and makes arc downward direction. If I put downward direction means it will be makes the arc in a upward direction like this. Like this होता था. I will explain. देखो इधर ऐसा होता था. ऐसे. Clear है ना? Sorry, this is not right. Just a minute. I will mention clearly. देखो इधर ऐसा होता था. ऐसे. If alpha 1 is less than alpha 2. Clear है ना? कोई बात नहीं. For this particular reason, you just think in the way how I am taking. It is actually basically depending upon the alpha value. Okay, and then here dt. That's why here I will write alpha 2 as a linear coefficient of expansion of a copper wire, alpha 1 for the steel. Clear enough up to this point? Okay, if it is clear means then we need to write the value of L1 and as well as the L2. L1 and L2 का वैल्यू पता करना है हमको. L1 देखो, yes, good guys. देखो इधर ध्यान से सुनो. Here this is the first arc which is made by copper. This is the second arc which is made by steel. इसका लेंथ L2 है, इसका लेंथ था L1. ओके गाइस इधर देखो, दिस इज एक्चुअली वी रिक्वायर्ड. ये L2 है मान लो. ओके, L2 का लेंथ पता करना है मींस कैसे पता करता है? एक्चुअली देखो, दिस इज नथिंग बट आर्क लेंथ. करेक्ट ना? L2 is nothing but arc length. This is radius. Right? If you want to find out the arc length means कैसे लिखते हैं आप? Arc length will be equal to r into theta. R into theta. Arc length का वैल्यू इधर क्या है? L2 मान लो. ओके, एंड r into theta लिखते हैं आप. क्लियर है ना? ऐसे लिखते हैं आर्क लेंथ को. इन अ सिमिलर वे इधर, here in this equation L2 means it will be come from this point. इधर L2 का वैल्यू क्या होता है, R के साथ D भी जोड़ना पड़ता है. We need to add R plus D, right? इधर देखो L2 value will be equal to R into theta only, but R का value is from 0.02 means O to D up to this point. Thickness भी add करना है, hence it will become R plus D into theta. Clear? I will call this equation number 3. Next, similarly L1 को find out करना है. L1 means up to this point only. Up to this point means L1 का value will becomes to be R into theta. I will call this equation number 4. Equation number 4 बन गया. Clear है ना? Actually our aim is to find out the value of R. R value find out करना है. इसलिए मैं क्या कर रहा हूं ना, इधर देखो इक्वेशन 1 और 2 है ना, इसको डिवाइड करता हूं. मैंने क्या कर रहा हूं, डिवाइड कर रहा हूं. डिवाइड करने से L से L कैंसिल होता है and dt से dt कैंसिल होता है. Remaining thing will be here L2 divided by L1 will be equal to alpha 2 divided by alpha 1. इधर देखो linear coefficient of expansion is directly proportional to length. How much length it is expanding. Clear ना? And similarly here equation 3 and 4 है ना, इसको भी डिवाइड करता हूं मैंने. राइट? डिवाइड करने से क्या मिलता है आपको, L2 by L1 वैल्यू मिलता है. राइट? एंड पुट दिस L2 by L1 वैल्यू इन दिस इक्वेशन. ये इक्वेशन के ऊपर सब्स्टिट्यूट करो. सब्स्टिट्यूट करने से क्या मिलता है देखो, alpha 2 by alpha 1 in the place of L2 by L1 I'm replacing this one, R plus D theta divided by R into theta, because we need to find out the value of radius. Then R plus D into theta divided by R into theta. Theta get cancel, no? Right? What I'm saying? Keep this equation in your mind, guys. I will write this one in the next page. किधर next page में solve कर रहा हूँ. Alpha 2 by alpha 1 is equal to R plus D divided by R. Up to this point, there is no doubt, right? There is no doubt up to this point. If you have any doubt means let me know, I will solve it. Okay, next page देख रहा हूँ. Alpha 2 इधर लिखता हूँ मैंने, क्या आ गया था हमको, Alpha 2 divided by alpha 1 is equal to R plus D divided by R आ गया था. Cool, good ध्रुचा. ये दोनों को डिवाइड कर लो इधर. ओके, दोनों टर्म को डिवाइड होता है. Then it will become R alpha 2 divided by alpha 1 is equal to इधर R by R plus D by R होता है. D by R cancel, no? Then alpha 2 by alpha 1 is equal to 1 plus D by R. 1 plus D by R. Actually we required R only. Take 1 to left hand side, then it will become alpha 2 by alpha 1 minus 1 plus 1 था minus 1 होता है into D by R. Next देखो क्या होता है, again इसको सॉल्व करो. ये टर्म को पूरा सॉल्व करने से अल्फा 2 मल्टीप्लाई करो 1 को अल्फा 1 माइनस अल्फा 1 डिवाइडेड बाय अल्फा 1 इज इक्वल टू D by R. Actually we required R, no? That's why change this denominator and numerator. इधर भी क्या होता है, चेंज होता है. Then it will become alpha 1 divided by alpha 2 minus alpha 1 is equal to R by D. क्लियर है ना? R को इक्वेशन चाहिए, D को लेफ्ट हैंड साइड मल्टीप्लाई करो. Then R value will be equals to, मल्टीप्लाई करो इधर, alpha 1 D divided by alpha 2 minus alpha 1. इधर alpha 1 है ना, coefficient of expansion of this copper, alpha 1, right? And then alpha 2 minus alpha 1 means difference between a two coefficients. इधर स्टील का था coefficient of expansion alpha 2, ये दोनों को difference. And D है ना, this is actually thickness of this bimetallic string. ये तीनों चीजें के ऊपर एक्चुअली हाउ मच दैट आर्क विल बी बेंड होता ना हीट देने से, इट इज डिपेंडिंग एक्चुअली this radius is depending upon three factors. First one is actually d, thickness कितना है, right? Second factor है alpha 1, coefficient of expansion of that particular material, and as well as the alpha 2. This is all about bimetallic strip. Clear है ना? Let me know, is it clear? अश्विनी, भावना, केदार, प्रसाद, कोमल, ऋतुजा, साक्षी, स्वप्निल, is it clear? Yes. From which school you are? Yes, good. And then we'll move to the next slide. Yeah, today we'll talk about one more important topic actually, guys. Which one I will explain first? First I will explain this one. Okay, देखो इधर anomalous expansion of water. Anomalous expansion of water. दादा पाटिल महाविद्यालय खजरात. Great. Great guys. Okay, इधर anomalous expansion of water है. Actually एक वाटर का अलग प्रॉपर्टी होता है, वाटर का एक अलग प्रॉपर्टी होता है, उसको हम कहते हैं anomalous expansion of water. ये क्या है वो ये न्यू प्रॉपर्टी, क्यों इंटरेस्टिंग फैक्टर, आई विल एक्सप्लेन दैट वन. देखो इधर फर्स्ट स्टेज यही है, ये बीकर है, बीकर के अंदर एक पानी है, ये एक नहीं पानी है, मान लो आई एम कंसीडरिंग ओनली वन ड्रॉप ऑफ वाटर. ओके, दिस इज अ वाटर ड्रॉपलेट. Okay, if I'm going to give the amount of heat to this drop of water, what will be happen? Actually this water droplet absorbs all the amount of energy which will be provided from another end source, and इसका वॉल्यूम क्या होता है, बढ़ जाता है. देखो इधर प्रीवियस वॉल्यूम था V, नाउ इसका वॉल्यूम हो गया V प्लस dV. वॉल्यूम बढ़ जाता है. When its volume will be increases, its density क्या होता है, डिक्रीज होता है. करेक्ट ना, रो वैल्यू डिक्रीज होता है, राइट? When density decreases, it tries to move upside in a water only. मान लो इसका वो पूरा पूरा वाटर भरा था, bottom of the water droplets are heated and their energy increases, volume increases, density decreases. When its density decreases, it will move upside of the water surface, and this place will be occupied by neighboring molecule of water. Correct ना? Okay, टेम्परेचर इंक्रीज हो गया ना, बिफोर टेम्परेचर T था, T1 था, इधर टेम्परेचर अब T2 बन गया. On giving supplying amount of heat, temperature also changes. देखो इधर ड्यू टू चेंज इन टेम्परेचर, ड्यू टू चेंज इन टेम्परेचर क्या हो गया, वॉल्यूम भी इंक्रीज हो गया. वॉल्यूम क्या हो गया, इंक्रीज हो गया. ओके, मान लो नाउ हाउ व्हाट आई विल डू, I will receive the amount of heat what I given. I can't receive directly. If I keep this beaker to normal condition. Normal condition means in a nature. Nature में रखने से क्या होता है, water actually what it is absorbed by the system, it will be released to the again nature only. At the time it comes to be cool down, cool down, cool down. Correct ना? Again the volume क्या होता है, decrease होता है further. Means heat receive करने से back volume will be decreases and again it will be replaces its original position. Cool. Further मान लो इधर था 10 डिग्री सेल्सियस, कितना है 10 डिग्री सेल्सियस है, मान लो now it is 10 degree Celsius this water. Okay, now what I will do, I will keep this temperature 10 degree, that time water will be in a state of water only. Now I will receive this water further. क्या कर रहा हूं, इसके अंदर है ना टेम्परेचर में, ये वाटर का टेम्परेचर अगेन डिक्रीज कर रहा हूं. डिक्रीज मींस अराउंड अप टू 4 डिग्री सेंटीग्रेड आई विल decrease. When I decrease the temperature of this system, volume also keep on decreases. Volume क्या होता है? Decrease हो जाता है. After reaching 4 degrees Celsius, if you are going to further decrease the temperature को further decrease करने से volume of the water होता है ना, volume क्या होना था? Volume decrease हो गया था, decrease होना है अभी भी, but after 4 degrees Celsius, if you further decrease in water, volume will be start to increase. क्या होता है? Volume start to increase. Increase होने से again volume increase होता है. At one certain point 0 degree centigrade it will become ice होता है, and volume भी बहुत बड़ा होता है, and it will comes to the topmost point of the water layer and it will start to float हो जाता है. Clear ना? But after reaching this topmost layer 4 degree Celsius, remaining all layers होता है ना, इधर ice बन गया है this layer, remaining all layers will be keep this temperature as an 4 degree centigrade only. 4 degree centigrade only. देखो एक ग्राफ बनाता हूँ. If I draw a graph means you will get definitely understood this one. क्या है? Y axis में वॉल्यूम लेता हूं मैंने, वॉल्यूम. X axis में टेम्परेचर लेता हूं. ओके, इनिशियली एट 10 degree centigrade, I will explain. Listen, 10 degree centigrade में water, ये क्या है guys? I'm taking water. 10 degree centigrade, water will be in the form of liquid. Correct ना? Its volume is constant, means high volume था, मान लो इसका वॉल्यूम तब बहुत बड़ा था. ओके, आफ्टर डिक्रीजिंग इन टेम्परेचर क्या कर रहा हूं मैंने? डिक्रीज कर रहा हूं. टेम्परेचर डिक्रीज करने से क्या होता है? वॉल्यूम आल्सो डिक्रीजेस. अप टू ए सर्टेन टेम्परेचर वॉल्यूम कीप ऑन डिक्रीजेस. After reaching a particular temperature, I call this one as an 4 degree centigrade. Further, if you're going to decrease the temperature value, okay, 4 degrees say again, if you're going to decrease means volume will not decrease. Instead of that, it will start to increase. क्या होता है? Volume increase हो जाता है. This process of water we called as an anomalous expansion of water. Clear now? Now it is clear, right? I will explain once again. I will clear this one. Okay. देखो, again I will explain. Here I will explain, guys. देखो इधर, ये water drop है. क्या है? Water है. Okay. इसको heat देने से क्या होता है? If you supply the heat means इस volume will be increases. V plus dV होता है. Now temperature also it is increases in this duration. सही है ना? मान लो ये initially 10 degree Celsius था. After giving this amount of heat, it will become 20 degree Celsius. Temperature difference, temperature increase हो गया. This is the first scenario. Second scenario क्या है ना? Now इस volume same volume V था at temperature 10 degree centigrade. Okay, now I'm going to keep this water inside a fridge. फ्रिज के अंदर रखता हूं मैंने. सिंपल है. क्यों? इसका एनर्जी एक्वायर करने के लिए, मींस रिसीव करने के लिए पैक. इसका टेम्परेचर क्या होता है? डिक्रीज होता है. टेम्परेचर डिक्रीज होता है. इफ टेम्परेचर डिक्रीजेस मींस वॉल्यूम क्या होता है? वॉल्यूम भी डिक्रीज होता है. नाउ V माइनस dV होता है. करेक्ट ना? ओके, नाउ मान लो टेम्परेचर डिक्रीज हो गया 10 डिग्री सेल्सियस टू 4 डिग्री सेल्सियस. 4 डिग्री सेल्सियस तक डिक्रीज हो गया. नाउ फर्दर यू डिक्रीज द वैल्यू ऑफ टेम्परेचर. 4 डिग्री सेल्सियस टू 0 डिग्री सेल्सियस तक टेम्परेचर डिक्रीज करने से अगेन वॉल्यूम शुड बी डिक्रीज होना था. बट इन दिस प्रोसेस ये दोनों टेम्परेचर का बीच में क्या होता है? इंस्टेड ऑफ डिक्रीजिंग वॉल्यूम, द वॉल्यूम विल गेट इंक्रीज. क्या होता है? वॉल्यूम इंक्रीज होता है. This is a special property of water. We call this one as an anomalous expansion of water. For this reason only, guys, in a polar region, किधर polar region, Atlantic region है ना, उधर aquatic animals like fishes होता है ना, समुद्र के किनारे में, okay, they are actually live because when they got ice, no, इसका density बहुत ज्यादा होता है, density increase होता है. Increasing in density means that all water means ice will come and float on the surface of water, right? Remaining remaining layers of water will be under 4 degrees centigrade only. Constant temperature maintain होता है. इसलिए aquatic animals can easily sustain their lifestyle under the sea water here. Is it clear, right? Anomalous expansion of water. Is it clear now? Rutuja, Sakshi, Prasad, Kedar, Bhavna, Ashwini. This is all about today's class, guys. Okay. We'll continue the class in tomorrow. Okay. Tomorrow we'll continue this one. Okay. Then see you there tomorrow. Until then, take care. Bye-bye. Sir, in winter, temperature is very... Yes, I got it. Just a minute. In winter, temperature is very low under the 0 degrees Celsius surface of water. River becomes ice, but under the depth of river or water present, it called anomalous behavior of water. No, Rutuja. Yes, Prasad. Okay. Thank you. Thank you, Bhavna. Actually, Rutuja, not like that. Actually, क्या है ना? Stay in a call. I will explain. Stay in a call only. कोई problem नहीं. Call में हो इधर. Be in a line. And so understood. You can drop the call. There is no problem. क्या है ना? देखो इधर रुतुजा. सुनो. ये aquatic region है. Right. Now, normal temperature है 10 डिग्री सेंटीग्रेड. मान लो 10 डिग्री सेंटीग्रेड. पूरा वाटर का 10 डिग्री सेंटीग्रेड है. ओके. नाउ if in case the temperature is decreases, temperature start to decrease. When it is start to decrease, इधर ये molecules का temperature क्या होता है? पहले decrease होता है. When it is temperature decreases, volume become very small. Okay. ये पहला volume था V. Now its का volume इधर है. This is V minus dV मान लो. Okay, temperature भी decrease हो गया. Now again, further decreasing in temperature, it reaches the temperature 4 degree centigrade. At the time, density बहुत छोटा था. After reaching 4 degree centigrade, again further temperature decreases means इसका volume further decrease नहीं होता है, increase होता है. When it is increases volume increases means density क्या होता है? Density will be increase होता है. आपको पता है ना, density is equal to mass by volume. Volume increase होता है means density decrease होता है. Density decrease होता है. When density decreases, it start to move upside and it will be locate here. इधर locate होता है ना top में. ये vacancy को neighboring water molecule will occupy this one, right? Thanks, sir. Mamta, Mahatma Gandhi Junior College. Yes, okay, bro. Okay, Prasad. Okay, good. Okay, this is now the ice will be come and settled here. Similarly, lot of layers of ice will be come and settled like this here. Okay, and remaining portion hota hai na, after reaching everything here, these are the ice. Okay, after remaining layers hota hai na, these layers actually will not further change in temperature hota hai. Change in temperature nahi hota hai because ice layer will not transfer the heat to the bottom layers. Are you getting my point? Or else no problem. Tomorrow I will explain once again this one. Okay, and you will get a clear idea about it. I will bring some simulation tomorrow. Okay, clear enough? Okay, that's better. Tomorrow we will continue this one.